Here's my AND logic gate on the SparkFun. As you can see, when both switches are off, the main one is off, and one switch is on. It's still off. And this switch is on, turns on, and then when this switch is off, turns off. Here is my AND gate. So you can see over here, got my first button and my second button here that are both going to their own transistor. Got the resistors on them. And over here, I have the LED, which is getting its input from the transistor, the resistor, and then power. As you can see, if I press one of the buttons, nothing happens. If I press the other button, nothing happens. But if I press both of them at the same time, then it's on. This is my AND gate truth table and schematic. Over here you see the truth table. If the inputs are 0 and 0, the output's 0. If there's 0 and 1, you still get 0. If it's 1 and 0, you also get 0. And if it's 1 and 1, you get 1. The only time you ever get 1 as an output is if they're both on. Over here you can see the schematic. You got both inputs over here, resistors and their transistors, and then you got ground down here and the output up here. So if both of them are on, leads the least path of resistance up through the transit, up to this resistor and to the output. And if one of them is off, it leaves the path of least resistance to the ground down here. Again, if this one's off, it just goes straight down, then this one will follow down as well. And if this one is off, they will both go down as well because it can't go up. Here's my OR logic gate on SparkFun. As you can see, when both are off, it is off. When one is on, it is on. When both are on, it is still on. When the other one's on, it's still on. Now here is my OR gate, just practically the same as the AND gate, except for this wire is running over to the LED as well, instead of just connecting the two transistors. Again, I have my buttons, my resistors, my transistors, LED with its resistor. As you can see, if I press one button, LED turns on. Press the other button, LED turns on. If I press both of them, turns on. And if I'm not pressing anything, LED's off. The OR logic gate truth table and schematic. For the OR, if you have inputs of 0 and 0, you get 0. 0 and 1, you get 1. 1 and 0, you get 1. 1 and 1, you get 1. Pretty much, if any of your inputs are 1, your output's going to be 1, always. So over here, you've got your input, resistor, transistor, resistor, another resistor, the ground, and the output. So this resistor's on, run up here, go through here, and straight to the output. And if it's off, it takes the path down here and then sees if this one's on. If this one's on, it just goes straight to the output. But if this one's off, they both go down to the ground. Here's my NOR gate with the SparkFun. As you can see, when they're both off, the NOT is on. When one gate is on, it is off. Both gates are on, it is still off. And when this gate is on, still off. This is my NOR gate. So here, again, it's all the same components over here with the buttons, resistors, transistors. It's just wired a little differently over here. So you give it a path of less resistance to go to ground. As you can see, if I press this button, it turns off. If I press this button, it turns off. If I press both buttons, it turns off. And when no buttons are being pressed, it is on. Table and schematic. Over here, you can see if we get 0 and 0, you get 1. 1 and 0, you get 0. 0 and 1, you get 0. 1 and 1, you get 0. So if either of the inputs are on, you're going to always get 0. Scanning you over here, you have both your inputs, resistors, your ground, your transistors, the resistor, and then your output. So if this transistor is on, if this transistor is off and this transistor is off, they will both go up to the output and turn it on. But if they're both off, or either one of them is off, they go straight down to the ground. And if both of them are off, they both go to ground. Here's my NAND logic gate on SparkFun. As you can see, they're both off, and it's on. One is on, it's still on. They're both on, it turns off. And if the other one's on, it's on. This is my NAND gate, where again I have the same thing. Buttons, transistors, resistors. Now if you see, if I press one button, it stays on. If I press the other button, it stays on. If no buttons are being pressed, it is on. If I press both buttons, it turns off. Logic gate, truth table, and schematic. If you have 0 and 0 as your inputs, you get 1. If you have 1 and 0, you get 1. 0 and 1, you get 1. 1 and 1, you get 0. So if you ever have 0 in your inputs, you're going to get 1 as your output. Over on the schematic, you have both your inputs, resistors, 2 transistors, and your ground. So if both of your transistors are on, it's going to send the power straight down to the ground. It's going straight down to the ground, not to your output. If either of them are off, then it's going to send it up to your output. If this one's off, it goes up, goes to the output. This one's off, same thing, goes up to the output. And if they're both off, it goes up to the output.